Hello, I'm Trey Porter, and I would like to thank you all for coming. In cooperation with Dr. Massey, I decided to do my research on fuel cell vehicles and hydrogen fuel cells. My presentation will cover 5 main topics, one being the polar PEM fuel cell, 2 fuel cell stack, 3 hydrogen production, 4 hydrogen storage, and finally what can these fuel cells actually do. Throughout my presentation, I'll be mentioning many elements, hydrogen being the most in particular, so it's important to know that hydrogen is the most simple element of all, as it is comprised of only 1 proton and 1 electron. As well, when it loses this electron, it is called the hydrogen ion, or H+. In the 1950s and 1960s, during the space race, NASA had started developing fuel cell generators for manned space missions. In cooperation with General Electric, the first polymer exchange membrane fuel cell was created. These fuel cells are complex systems that have 3 main parts that are vital to the entirety of the complex. This is what a fuel cell will look like, with a typical thickness of 1/4 of an inch to 1/2 inch thick. Although very thin, they do house 3 main parts. These parts are flow plates, anode and cathode, and a polymer exchange membrane. When all these parts come together, they will create an electric current that will provide power for many applications, including cars and other vehicles. The first main part being the flow plate. It is the outermost part of a fuel cell and is where hydrogen and oxygen enter. Thus, it is designed to provide adequate amount of these reactants to the fuel cell. These fuel cells, their flow plates provide 2 main functions. One is to channel the reactants to the anode and cathode, and 2 to channel water and heat away from the fuel cell. To complete these functions, there are many different flow paths that these reactants can take. 2 of which are the serpentine flow path and the multiple serpentine flow path. In the serpentine flow path, reactants, hydrogen and oxygen, are able to flow in a continuous path under pressure from start to finish. It is relatively efficient at distributing these reactants through. An advantage to this path is any obstruction will not block the path. However, a disadvantage is the reactants and pressure are often depleted due to the length of this path. In the multiple serpentine pathway, it's designed much like a serpentine pathway, except more channels help to reduce that pressure loss. But reactants are still depleted at a high rate. This is what a serpentine flow path would look like in real life. 2 more pathways are the parallel flow path and the interdigitated flow path. In a parallel flow path, they are dead-ended, which forces the reactants to flow under pressure through the pathway. And when looking at interdigitated flow path, they are different shapes like a circular, trapezoidal, and leaf-like layout. These change in shapes can help influence the amount of water and heat that go through the cell, which can improve performance. The second parts are the anode and cathode. They are both located just inside the flow plates. At the anode, hydrogen is separated into a proton and an electron. The negatively charged electrons are sent to the cathode, which creates an electric current. The protons or hydrogen ions are then sent through a polymer exchange membrane to the cathode to connect with oxygen flow plate and create water, which is the only byproduct of a polymer exchange membrane fuel cell. The anode is electrically negative and where oxidation takes place. Oxidation is the loss of electrons. So when we look at an equation, we can see that this is where hydrogen is split, causing the loss of the electron that is sent to the cathode. The cathode is electrically positive and where reduction takes place. Reduction is the gaining of electrons. So from that equation, we can see that the cathode is gaining the electron that the anode had sent. As well, the cathode is accepting the hydrogen ion, which passes through the polymer exchange membrane. This will then combine with the electron it had lost. Then it will combine with oxygen to produce that water. So our net reaction would be hydrogen and oxygen combined to make H2O. The last and final part of a PEM fuel cell is the polymer exchange membrane. A membrane is simply a selective barrier, so the polymer exchange membrane is called this because it refers to the area of the fuel cell that selectively transfers those hydrogen ions from the anode to the cathode. This is very important because those hydrogen ions need to reach that cathode to provide oxygen to produce water. To do this role successfully, the PEM is required to have certain physical and chemical properties. It must be have good ion conductivity. It must be chemically stable. And it must have the ability to form thin films, among other characteristics. So when we take a look at the system as a whole, first we start with the flow plates. This is where hydrogen and oxygen enter the fuel cell. Then The hydrogen passes through the anode and cathode. The anode will separate it, send an electron around to the cathode to provide that electric current, which we'll use to power your car. Then the proton will go through the PEM to combine with the electron at the cathode, then to combine with oxygen to create the water that travels out the other end of the flow plate. So one fuel cell can only generate about 1 volt or less of power, which is much too small for upscale operations like vehicles and generators. So to increase these power outputs, they must be placed in a fuel cell stack, as seen in the picture. These stacks can range from 5 fuel cells to hundreds of fuel cells. Once in these stacks, they are capable to be used for more useful operations like generators and vehicles. So with the primary source of reactant being hydrogen, it is also important to know how hydrogen is isolated for use. This can be done in many ways, including natural gas reforming and electrolysis. In natural gas reforming, it's the cheapest and most common. They use a mixture of carbon monoxide, which is reacted with water. This process is completed in many ways using water gas shifting. This also can be shown in the form of an equation, which we see carbon monoxide reacting with water and heat to produce carbon dioxide and that isolated hydrogen. The process of electrolysis looks very similar to a PEM fuel cell, in which an electric current is used to split the water into hydrogen and oxygen. This hydrogen will then react at the anode, which will take that electron, send it to a cathode, which creates the electric current. The hydrogen ion is then sent through a PEM, which combines with the electron lost at the anode. Then this will create hydrogen gas in the form of bubbles. So when we look at vehicles, it is also important to know how to store this hydrogen that's being produced. It can be stored in 2 forms, liquid or gas. When it is stored in the liquid state, they must use cryogenic tanks. The tanks must be negative 254 degrees Celsius because the boiling temperature of hydrogen is negative 253 degrees Celsius. These tanks can be used in labs, transportation, or other uses. But when stored in a vehicle, they will be stored in the form of gas. As a gas, they'll be used in compressed tanks ranging from 5,000 to 10,000 psi. There are 5 main parts, 2 on the outside and 3 on the inside. On the outside, there's an impact-resistant dome and a manual valve or in-tank regulator that will regulate how much of the hydrogen enters the fuel cell. On the inside of the tank, there are polymer liners, a carbon-reinforced shell, and a reinforced external protective shell. These shells will protect from corrosion of the hydrogen as well as impacts. So what can these fuel cells actually do is they can create buses and cars. Currently, buses are being used in California, Australia, Beijing, Brazil, and many other places. For cars, many top manufacturers, including Toyota, Honda, Mercedes, and Hyundai, currently have fuel cell cars. However, due to the lack of hydrogen gas pumps in the US, they are mainly only found in California. And as well, currently in research are planes. Boeing is currently researching a commercial plane powered solely on PEM fuel cells, and they as well currently have a 1-person hydrogen-powered plane. So in conclusion, in researching these fuel cells, I found that they were very interesting and complex systems. Every part within them holds a sole purpose, and without one, the entire system would be flawed. With the only byproduct of water and oxygen, the fuel cells is one of the most environmentally friendly sources for power as well. But in terms of cars and other vehicles, I don't believe they will become as popular or become the cars of the future because of the price to build a hydrogen fuel pump, and as well as the competition and simplicity of the electric cars now. But when looking ahead, I do believe that these fuel cells will become a very viable source for energy in the future. Thank you. Is there any questions? Yes.
What was the favorite thing that you learned from your normal power conversion?
My favorite thing was just figuring out how these fuel cells work. I mean, looking towards the future, everybody wants to try and get away from the gas and oil. So I think it was very interesting learning one of these alternative fuels that really could help our environment and help move towards a better environment, really. Yes. Yeah.
So, if we
Both. They're in research here and other places. Hydrogen is one of the most abundant elements we have in our atmosphere, so it would be viable to figure out how to make these more often and more cheap. But due to all the carbon fiber involved in them, they're very expensive. But I think as it goes on, they'll get cheaper and cheaper. It's just kind of trying to drive that price down to be able to research them fully. Yes? Yes, that's why they're typically found in California, just because that's the only place in the US that has hydrogen fuel pumps. Hydrogen is fairly expensive. It's about $6 per gallon, but these gas tanks can only hold about 6 gallons of that hydrogen. So your range for vehicles is around like 360 miles. It's just kind of unfortunate that they're not widely spread across the US. Yes?
You mentioned that they actually have like a plane, a 1,000 plane that they could use. Have they tested to like long distances, or is it just a short distance that they can fly?
I think it's just short distances for now. It's just a simple propeller plane, so it just flies over California, just kind of as a research beacon for bigger commercial planes that they're researching. So I think as they continue to do that, they'll be able to get more and more into that distance length.
Do you know how long they can keep it fly?
I do not. I have not looked into that. Yes? I have not found any. I mean, being the only, instead of releasing the carbon dioxide and stuff like cars now, the only byproduct is water. So you can literally put a glass under the tailpipe and collect it. But other than that, there really hasn't been any side effects. With the storage tanks, they're all one of the external protective shell is fairly bulletproof, so it won't puncture, so you won't have any issues there. They haven't had any issues of that, so I haven't found any major side effects from it. Yes? They kind of differ for whatever you want to use. I certainly found that the Serpentine flow path was the most widely used. That could be either because it's just cheaper, so it's not as in-depth with that flow path, but that certainly is the most common flow path I found that is the most widely used. Yes?
So if prices are equalized, are electric vehicles or fuel cell vehicles?
They're about the same. The miles per gallon range on a fuel cell vehicle is about 60 miles per gallon, but you can only use that 6 gallons of hydrogen that you put in the car. It's also with electric. I mean, you see those charging stations everywhere. From gas stations, we have some outside here. So they're just more widely used because of that. Yes? Yes, they currently now have portable chargers, so you can plug your Apple charger in, charge your phone, charge that. Hawaii currently has one as a big generator. You can buy small generators, just backup generators. So there are definitely more uses for them. That's why I believe they are going to become a very viable source for the future. Alrighty, thank you.